Hello everyone, my name is Łukasz Husarz, this is my friend Marcin Paluszek. Today we want to share our story of how we moved our game servers from classic, typical on-premise bare metal servers to Kubernetes. We will show you what problems we had before, how we solved them, and what we learned along the way, and maybe you can take something away.
All right, so what we had before. Let me quickly show you our legacy architecture, and I will just cover the most important parts. We have a lot of dedicated servers running different types Java-based game components, and the core of any games are game server instance. So we have game server hosts. Next are services, and they are really important, so we're trying to keep them on separated, dedicated machines. So we have service hosts. We also have special hosts for arbiters, but I will talk more about them later. Then are also utility hosts. They run our tools and maintenance scripts. HA proxy is our load balancer. It routes traffic to the game server instance and services instances. And we also have database servers, but they are not migrated yet. Why? First of all, we use Redis, a lot of it, over 1 terabyte in total. So we won't migrate them because they are too big. But we also have small PostgreSQL instances that we will likely migrate soon. We are currently testing some different solutions with Postgres on Kubernetes. And everything is managed by Puppet. What can I say about this setup? It looks good on paper. It works also pretty well, to be honest. We didn't have a lot of problems with that configuration, but recently some on-prem daemons started showing up more and more. And speaking of daemons, we are in Slovakia, right? But if we are talking about our daemons, let me show you the first one, and its name is Arbiter. Arbiter is a very specific service. We don't have time to go into all the details, but in short, it takes care of some of the game's most important features, like championships, leaderboards, or duels. So it means that it's absolutely essential. Without it, the game simply doesn't run. And to make it even harder, only one instance can run at a time. It's related with keeping the data consistent. So implementing good and fast working redundancy or failover, in our case, let's say it's complicated. So to sum it up, it's a classic single point of failure. And now imagine that one of the write disk fails on the host running the arbiter. So we have to request disk replacement on this host, and we have to move the arbiter. And how does it work? Very fast and easy. We only need to find a new host with enough free resources and prepare it using Puppet. It takes some time. When we've got host ready, we need to wait until midnight, because that's when player traffic is lowest. And as I already told you, stopping the arbiter means that entire game stops. So we definitely cannot do this in our peak time. When we've got host ready and write time, we have to go through several important steps, always with close coordination with one of our developers. And that's not all of them anyway. There are more, like switching database connection. But let's just say these are the most important ones. After we finish our migration, we also need to remember to clean up the old host, just to be sure that old arbiter instance doesn't accidentally restart. So finally, after all these things, we can request disk replacement on this host. So yes, I was joking with that fast and easy at the beginning, but hey, it always could be worse, right? Because last time we saw we lose a disk. What about now? What if we lose the entire host? Right now, the game is down, so we are not waiting until midnight. We have to respond right now. We have to go through all these steps as soon as possible to bring the game back. And at this point, this is pretty much what we look like. Pretty stressful situation, right? But if we are talking about stressful situation, let's talk about another our demon. Let's talk about infrastructure scaling. And I have another real example from our company. We had situation that we launched featuring in new country. Specifically, it was India, so quite a big country with a lot of people. And in first month, we recorded a huge number of new game installs, which was significant percentage increase. And that kind of growth made our servers start heating up more and more. And we really didn't want them to end up like this. So we took a number of steps to protect ourselves. First, we tried to scale up our infrastructure with adding more game server and more services instances. And we used all our spare capacity with resources we had. We also need to change the HA proxy configuration to rebalance player traffic across new instances. But even after that, the growth was just too big. So we had to order additional dedicated servers. And when we did it, the featuring in this country was shut down. So we took our cost, we took our time, and we ended up with brand new but unused dedicated servers. So we ended like this.
Okay, all of those things were frustrating for sure, but not just only for us. Imagine situation like we have 50,000 players online and everything is going fine until we find a bug that 100 players can't log in. 100 doesn't sound like much, but some of them might be our biggest spenders, so players who pay a lot and expect smooth experience. So we've got two options. We can wait to the late night, but that means the 100 players are still locked out for hours. Or option two, we can deploy fix right away, but that means relogin for all our players, trigger some lags, and what if we need to fix our fix? We need to do it again. In the end, none of these options are okay. No matter what we choose, someone will be upset. So let's sum up the pain. No self-healing. If something broke, we need to fix it by hand. No autoscaling or flexibility. And the most important, most painful deployments. Every deployment meant restart of Java, which meant relogin of all our players, which meant angry players. So after enough pain, we started asking ourselves a question, how we can fix this, how we can make our life easier and our players happier. And the answer was quite obvious, Kubernetes. And we already use Kubernetes on GCP with all of the stuff like Argo, Cert Manager, Prometheus, Vault, Ingress, Nginx, etc. So we knew it's a power. But we asked ourselves another question. What we really want? Kubernetes in cloud, like GKE, or maybe self-hosted Kubernetes. So let me ask you a question. What would you choose? Raise a hand for cloud and GKE, like this. 1, 2, 3, 4. It depends, of course, always it depends. How many about self-hosted? Okay, there is more. Well, we went with self-hosted also, mostly because of the cost. but also because of the latency. We set up the cluster in the same DC where our game databases live, so we've got lower latency and save some money. Now you might ask, why K3s? Why this particular distro? We had experience with using Kubernetes in GKE, but not really know about setting the cluster ourselves and managing it. So for sure we had lack of knowledge. So we wanted something simple, easy to start with lower entry barrier, but something to fully supports high availability and is ready to run real production workload. And K3s gave us that balance. We treated all of this like a real project. So we set up with the product team, discuss about the idea, about the risk, about how the success would look like. Then we made a task and split work between the teams, so everyone knew what to focus on. Next, we made a simple timeline, how we wanted to move forward, but no rush. No rush is important because of the tests. We knew that production stability and players are our top priority and most important thing, so we need to test really carefully everything. So we have everything ready, and test environment was up, images were built, Helm charts were in place, secrets involved, everything ready to go. And we started our journey with Ingress Nginx. Why? Because we use it in GCP on GKE and it works super well. But soon we ran into some problems. First, no sticky sessions based on our custom bottle session header. Imagine situation like players when they are playing switch the internet from Wi-Fi to mobile on their phone. That causes players jumping between bots and breaking their sessions. Not acceptable for us. Second thing, no native canary deployment support, and this is an important feature for our developers. And the third thing, no real preservation of client IP. In tests, every player looked like they were from Poland. So our analytics are totally useless at this point. And you can only imagine faces of R&D guys when they realize this. Totally disaster. Of course, we could solve all of these problems with workarounds, maybe custom solutions, but then we looked at Istio, and Istio gave us everything out of the box. So we started with Istio. At every stage of the project, we kept one thing in mind, our players. We didn't want just cool new setup, we wanted something better, that we tracked key players' metrics just from day one, metrics like how long they played, how many activities they did during a session, how often they had to relog in. And these metrics help us a lot to compare the new infra to the old one, using real player behavior. So, let's talk about one of our demons, deployment. Before, every deployment meant restart of Java, which means relogin of all our players. Now we use rolling update, and when the rolling update starts, the new players are routed to the new version on fresh pods. Old active players who are already active stay on the old pods and playing without any interruption. The old pods stay alive for 45 minutes, which is custom and it's more than our average session length. Or if pod has no more active sessions, it can be shut down earlier. And we control this with a custom press stop script using Prometheus metrics to check active player sessions. Okay, we also introduced new deployment methods, and our developers especially loved canary releases. Why? Because they can release a fix or a new version to just small percentage of players and test it. If everything's fine, we can roll out to everyone. And we control this with in our Helm charts with simple switch enable false true, and the developers did this by themselves. And this is how it looks. How it looks in our case. This is visualized in Kiali. Kiali is a graphic console for Istio service mesh. And we can literally see request flow with things like response time, traffic rate, etc.
All right, so first demon defeated. It's excellent news. The next one we had to face was scaling, or rather the lack of it. And of course, Kubernetes comes with a powerful tool to fight it, autoscaling. Thanks to that, we can easily make sure that our servers don't end up looking like this, but like this instead. Okay, but how? With basic horizontal pod autoscaler, we don't need to adjust resources manually. We can define the limits once in our Helm charts, and Kubernetes handles the rest. Here is our baseline. We set a minimum of 5 and maximum of 16 pods, and tell Kubernetes to scale up or down based on CPU usage. In this case, it was 80%. It was simple. It works well for normal traffic, but we needed something smarter. And here comes KDA, Kubernetes event-driven autoscaler. With KDA, we can scale not only based on metrics like CPU, but also on events or time-based triggers. And this is perfect solution for our games. Why? Because we know that at 15 o'clock in one of our games, the event starts, and it always brings sharp spike in traffic. So instead of waiting for CPU to spike, we can scale before it happens. Here, we trigger scaling just 10 minutes before 15, just to be ready in time. And after half an hour, when the peak is over, it scales back down automatically. So we tested first solution with basic horizontal pod autoscaling. Then we tested KDA. But one day, unfortunately, we tested both of them in the same time. Why not both? We already know, so let us tell you how it went. We have some incident. It all starts with a config change. We thought we had disabled KDA by setting enabled false in our values, but what we didn't realize is that the scaled object and KDA autoscaler were still in the cluster. In the same time, we turn on the basic horizontal pod autoscaler because, like I said, we want to test something, and they both started to scaling the same deployment. To be honest, it looks exactly like this. We blinked and boom, a whole pod farm just spun up in one moment. At this point, it wasn't scaling anymore. It was a fight. 2 autoscalers, only one deployment. One scaler was triggered by CPU usage, the other one by cron. Each thought it was doing the right thing, and neither one knew the other exists. So no coordination in this case means no mercy, just chaos. What was the result of this fight? Over 40 pods running, many of them stuck in terminating, some in pending. With that many pods sending requests, our databases got completely jammed. We basically blew up our own cluster with own autoscaling. So we can say it was our fatality. What did we learn? Disabling something in your values doesn't mean it's actually gone. So remember, always clean up leftover resources. Okay, we already taken some hits. Let's try to recover. Let's talk about another fundamental benefit of Kubernetes, about self-healing. And it means that if something breaks, the system tries to recover automatically without manual intervention. So in case of pod crash, a new one is created. In case of node fails, workloads is sent to a healthy one. And to handle this even better, we can use props, They are telling Kubernetes when pod is ready, healthy, or needs help. Self-healing minimizes a lot failure risk and downtime, especially after working hours, but it also makes maintenance much easier. Because do you guys remember that story about migrating the arbiter? This one with late nights, developers, and step-by-step coordination? Well, we didn't have to wait long for a real test. Another disk fails, and this time it was on one of our worker nodes. But this time, we don't have to go through all the steps anymore. And moving services is fast, this time for real. How fast? Actually, can I ask all of you for a quick favor? Let's all snap our fingers once. At 3. Come on, I know it's late, but come on. 1, 2, 3, snap. Okay, that's it. That's exactly how long it takes now. It wasn't exactly Thanos snap, of course, but it was almost so powerful. One comment, one person, with just one comment, the cluster take care of the rest and start to moving workloads to another healthy node. We only need to wait until all pods have been terminated. So, huge difference with our time and effort. And self-healing was the cure for our last demon, right? So now we can say goodbye to this dark and evil threat. But we are still in Slovakia, right? So please welcome a legendary Slovak hero, Janko Hraško. In original story, he was born from a pea, but in our story, he jumped out from one of our Kubernetes pods. He is very tiny, but also very clever and smart, and he promised us to help us and keep watch to our Kubernetes cluster.
It's super fun that we have a new hero because the adventure is not over yet. And right now we are in progress of migrating our biggest game, the final boss of the project. And then we want to improve our observability, especially with tracing. And tracing will help us to understand performance and issues across our services. And once all our games run in the same cluster, we will be able to share resources between them because different games have different peak times. So we can reduce waste, save some bugs, and that's all. If you want to check one of our zero downtime game, you can scan the QR and experience zero downtime. And I guess that's all from us. Thank you very much for attending in the late hour.
Okay, now when my mic is working, we have some questions. Did it require a lot of effort to adapt the game for Kubernetes? What are the challenges related to players managed by one pod interacting with players connect managed by another pod?
A lot of effort. I guess in our case, not really, because we have pretty nice developers. One of them is sitting right there, and he built a Java image in, I don't know, maybe 3 days. So most of the time it's about testing, about challenging the ingress with Istio, etc. But build the image and set up all things to test, it was pretty easy. And shared resources. We have only the pods running the Java game are the same. We don't have any other stuff on Kubernetes yet. We will have maybe the databases but not right now yet.
Thank you. You mentioned autoscaling the app pods. How did you manage to scale the arbiter? If there is only one, is it shared between game titles, or you have a separate arbiter per each game?
Each game have their own arbiters, and they are not sharing resources between the other one. And still, it can be only one pod deployed at the time. So when the nodes, worker node that's running their arbiter are down, it will be still a little bit of downtime, but not that much like we have on the on-premise. So we only reduce downtime and effort to manage the arbiters, but not 000 when arbiter host is down. Because of the architecture of the game, we cannot change it.
This one I wanted to ask what somebody else did before me. So why did you choose K3s as Kubernetes distro? Isn't that suited for like a small clusters, IoT and...
Yeah, as I mentioned in the presentation, mostly because of the lack of knowledge at the start, when we start thinking about Kubernetes in our company. And K3s, I found some case studies that people run real production workload on K3s, but on paper it's a distro for small things. But I think we can say we prove that we can run real heavy production workload. We have right now 3 clusters of K3s, one for our games, one for R&D, and one dev environment. So we can recommend K3s right now. Zero problems with that. A simple update, deploy of the clusters took us, I don't know, maybe a few hours to set up and running. But basically because of the lack of knowledge, I think, at the starting point.
You were lucky, which is important.
Yeah.
Okay, and the last question so far, why do you auto-scale pods when you have on-prem environment? Do you have other workload which can use spare capacity on clusters?
Right now, the cluster for games running 2 separate games, and we are migrating the third, the biggest one. And auto-scaling is mostly because of the different peak times. And let's say one game have peak time at 15 o'clock and one at 1 p.m. So the workload is balancing between the nodes, and we can save some bugs for the machines when we use this.